Hello and welcome to TeachUp, where we train you to do well on the AP Calculus test and to do it fast. Today we will look at a continuity problem given this function g of x, which is a piecewise defined function. Which of the following statements is true? So g of x is equal to negative 2x plus 5 for x being less than negative 1, and g of x is equal to 2x squared minus 5x for x being greater than or equal to negative 1. Anytime we have a continuity problem, we need to remember what it means for a function to be continuous. Well, a function g would be continuous if the limit as x approaches, say, negative 1 here, so that would be a, but I'll just say negative 1 of g of x. If this limit exists, and if this limit is the same as g evaluated at negative 1. In other words, the function value is the same as the limit. So anytime we have that, the function would be continuous. And one more thing about continuity is because it's a piecewise defined function, we need to make sure that the limit of this function coming from the left-hand side is going to be the same as the limit coming from the right-hand side to make sure that the limit does exist. So let's take a look at that. The limit as x approaches negative 1 from the left-hand side of this function g of x is going to be equal to the limit as x approaches negative 1 from the left of now negative 2x plus 5, because as we're coming from the left hand side for those values that are to the left of negative 1 that are less than negative 1, the function is defined to be this linear function. Now we know linear functions in general are continuous, so the only problem here could have in terms of the function not being continuous would be at that point where the function changes from a linear function to a quadratic function. In general, again, the quadratic function is also a continuous function, but we're just going to check at that borderline there, at that point, x equal negative 1, what's happening. So substitute negative 1 into this function, we would get negative 2 times negative 1, which is going to give us a positive 2 plus 5. So here the limit is going to equal to 7. Now, similarly, we have to check the limit as x approaches negative 1 now from the right-hand side of the function and see what we get. This is going to equal to the limit as x approaches negative 1 from the right-hand side of, and that function was 2x squared minus 5x, 2x squared minus 5x as we're coming from the right-hand side. So for those values that are greater than negative 1, and in this case, greater than or equal to negative 1. This is going to equal to 2 times negative 1 raised to the second power minus 5 times negative 1. Well, negative 1 to the second power is 1 times 2 is 2, and then negative 5 plus times negative 1 is plus 5, so we get a 7. So this tells me then that the limit of the function exists and it equals 7. Now we're just going to make sure that the function value is 7, and then we could say that g is continuous, and it is, because we're going to see here that g of negative 1 is defined to be what we just found in our last calculation. So g of negative 1 is going to equal to 7. That's what we just found here. And so that tells us that the limit is equal to the function value and all of it is equal to 7. Therefore, our answer here is that the function is indeed continuous at negative 1.